Have you ever wondered how transistors work? Today, we're diving into the incredible world of transistors, the unsung heroes of the digital age. These tiny wonders are the building blocks of all modern technology, silently powering our computers, mobile phones, and countless other devices. Imagine a bustling city, with traffic flowing smoothly thanks to a network of traffic lights. Transistors are like these traffic lights, controlling the flow of electrical signals within our devices. From the moment you press the power button, transistors are at work, keeping the digital world at your fingertips. Their importance can't be overstated. Without transistors, the digital revolution would have been impossible. We wouldn't have smartphones, laptops, or even digital watches. Our lives, as we know them, would be vastly different. Transistors truly are wonders of the modern world, integral to the technology we rely on every day. Now you might be asking, what exactly is a transistor? A transistor, in simple terms, is a tiny switch that controls the flow of electricity. It's the unsung hero of our modern digital world, sitting quietly within our devices, making sure that the right amount of electricity goes where it needs to. Now let's get into the nitty-gritty of what makes a transistor. Picture it as a sandwich with three layers. The top and bottom layers are called the emitter and the collector, respectively. The middle layer, the base, is the real game changer here. These three layers aren't just randomly put together. They're meticulously designed and layered with specific materials to carry out their roles in the operation of a transistor. So, what's the role of each layer? Let's start with the emitter. The emitter's job is to emit or throw out charges. It's the starting point of the electrical current. It's like the pitcher in a baseball game, ready to throw the ball into play. Next up, we have the base. The base is the thinnest layer of the three, and it plays a crucial role. It's like the catcher in the baseball game, ready to catch the ball thrown by the pitcher. But here's where the analogy changes a bit. The base doesn't hold on to the charges, instead it lets most of them pass through to the collector. It's this passing through that allows the transistor to control the current. Finally, there's the collector. The collector's job is to collect the charges that pass through the base. It's like the outfielder in our baseball game waiting to catch the ball that's been thrown and passed. The collector then sends these charges onwards, completing the electrical circuit. And there you have it, the basic structure and function of a transistor. It's a tiny, yet powerful switch, controlling the flow of electricity within our devices. Now you may wonder, how does this tiny switch actually work? The working of a transistor is a fascinating process. Picture a sandwich, if you will. But this isn't your typical ham and cheese. It's a transistor sandwich made up of three layers: the emitter, the base, and the collector. The key to understanding how a transistor works lies within these three layers. The emitter and collector are similar, both made of a type of semiconductor material called N-type, which has an abundance of free electrons. The base, which is sandwiched in the middle, is made of P-type semiconductor, which has deficiencies of free electrons, or holes. Now imagine sending a small amount of electric current from the emitter to the base. This current is like a crowd of people, the electrons, trying to get through a narrow gate, the base. Only a few people can squeeze through at a time. But here's the magic part. This small current that squeezes through the base controls a much larger current that flows from the emitter to the collector. It's like the crowd of people now has a clear, wide-open path to move through. This effect is known as amplification. In a nutshell, a transistor is a current amplifier. The small base current controls the larger emitter-collector current. The ratio of these two currents, known as the current gain, determines how much the transistor amplifies the signal. Transistors can also act as a switch, opening and closing the path for the current to flow. When a sufficient base current is applied, the transistor switch is turned on, and current flows from the emitter to the collector. When the base current is removed, the transistor switch is turned off, and no current flows. This simple yet powerful ability to control current flow forms the basis of many modern electronic devices, from radios to computers. So that's the basic operation of a transistor. But what happens when we use millions of these transistors? When millions of transistors work together, they form a complex network that powers our digital world. Picture this, an orchestra, with each transistor playing its part to create an intricate symphony of calculations and data storage. These tiny switches are the musicians of our digital age, each one working in harmony with countless others to perform the computations that form the bedrock of our technology. In the heart of your computer, for instance, the central processing unit, or CPU, is a hotbed of transistor activity. Each calculation your computer performs, each pixel it displays, each byte of data it stores, is underpinned by the rapid switching of these transistors. They're like the neurons in our brains, passing on signals, making connections, allowing our devices to think, remember, and act. But the influence of transistors reaches far beyond our computers. They're also integral to the operation of our mobile phones, allowing us to connect with people across the globe, browse the web, and capture memories with a simple click. Similarly, they're at work in our televisions, amplifying signals and refining images to deliver crystal-clear visuals and sound. These tiny powerhouses are the unsung heroes of our digital lives, quietly and efficiently carrying out their tasks millions of times over every second of every day. So, next time you use your smartphone or computer, remember the tiny switches that make it all possible. To sum it all up, a transistor is a tiny switch that controls the flow of electricity. These miniature marvels are the building blocks of our modern digital world, turning electrical signals on and off to perform calculations. They operate based on the principles of semiconductors, using a third piece, the gate, to control the flow between the source and drain. They're found in everything, from your smartphone to your car's engine, and that, my friends, is the wonder of transistors.